Hi, my name is Brandon Vella, and today we're going to be looking at some coordinate geometry. This lesson is actually a two-part lesson, so we're going to start off by doing coordinate geometry part 1 and looking at some simple graphing. Alright, so a basic graphing review. Here we have our coordinate grid, we have our x and y axis, and it's pretty self-explanatory. The farther you go to the right on the x-axis, the bigger your x value gets. The farther to the left you go on your x-axis, the smaller your x value gets. The same applies for your y-axis. The higher up you go, the greater your y value is, and the farther down you go, the smaller your y value is. And when you have a coordinate, your coordinate is made up of an x and y pair. That's called an ordered pair. The x always comes before the y, and in between is a comma. Okay, so when you have 2 points on a coordinate grid, in this case our points are 3, 3, and negative 5, 5. If you draw a line between those points, that line is going to have a slope. The slope is the change in y and over the change in x, or delta y equals over delta x if you want to be fancy. So looking at the line, since the point is slanted upwards and to the right, we automatically know that our slope, or our m in this case, is going to be a positive slope. So we plug in our coordinates. Our y's are negative 5 and 3, and that's going to be over our x's, which are negative 5 and also negative 3. It happened to work out nicely in this example. And then we simplify down, do some algebra, the negatives cancel out, and we get our slope is equal to negative 1, again positive, like I said it would be. And here are just some different examples of some other kinds of slopes. Here the line is pointed down and to the right, so we know it's going to be negative. And here we have a line of y equals some number all the way across. That slope is 0 because there's no slope, it's just a horizontal line. And here we have an interesting line where the slope is undefined. That's where there's going to be a 0 in the denominator, and if you are testing for a function, that line will not be a function. Okay. Slope-intercept form. Whenever you are writing a formula for a line, it's going to be standard notation, and that's going to be y equals mx plus b. And each part of that formula has a different, or each variable in that formula corresponds with specific information on your line. So your x and y correspond to the ordered pair. All right, that makes sense. M is the slope, which we previously figured out. B is the y-intercept. Now the y-intercept is going to be where the line intercepts the y-axis. So for example, if your point was, or if your line crossed through the y-axis at 0, 6, your y-intercept, or your b, would be 6. And here in this example, we see the line crosses the y-axis at 0, 1, so our b value is 1. And you plug it into the slope-intercept form, and you get your equation of the line. Okay, when you find midpoint, midpoint's just a fancy way of saying the average between the x and the average between the y. So we have for this line 2 points, 3 and 4, and 1 and 2. Connect that line, and we should get a midpoint of 2, 3. Now we have this big equation here. It looks a lot harder than it really is. What it's saying is you take both x coordinates, divide by 2. Both x coordinates, find the sum of those coordinates and divide by 2, comma, take both your y coordinates, sum them together and divide by 2, plug everything into the equation, simplify them, 4, 6 divided by 2, and 2, 3 is your midpoint as it shows you on the slide. Okay, the distance between 2 points. This formula is very important to know to find the distance. It's very useful when using Pythagorean theorem, and Pythagorean theorem is also derived from the distance formula. So we have 2 points, 5, 10, and negative 10, 5. So we're going to draw a line between the two of them, and we are going to get a line. We want to find the distance between the line. The formula to find the distance of a line is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, all under the square root. So let's just start plugging in our variables. We plug in our x, and we plug in our other x. And then we plug in our y, and we plug in our other y. Simplify what's inside the parentheses. And then we square what's inside the parentheses. And to finish, we sum the two things. We sum the whatever was inside of parentheses. And also, you always have to make sure when you're doing distance formulas to bring down your radical symbol, whatever. Make sure whenever you are doing these, whatever you are working so hard to find the distance formula for, you're always taking the square root of at the end. I didn't feel like doing the whole rationalizing or simplifying the radical, so I just left it as radical 450. You could probably simplify that, but for these purposes, we won't do it.